let's walk through SentrySearch, a Python command line tool that lets you search hours of video footage with a plain English query and get back a trimmed clip of the moment you wanted. The problem it solves: dashcams record hours of footage, but the moment you actually care about is a few seconds long. Scrubbing through all of it by hand is painful. The core idea is that modern embedding models can turn raw video pixels and a text query into vectors in the same space. So a sentence becomes directly comparable to a clip, with no transcription or captioning in between. The pipeline is 4 steps. Split each video into overlapping chunks, embed every chunk as video, store the vectors in a local Chroma database, then embed your query and match it against them by cosine similarity. The code is organized by responsibility: a command line layer, a chunker, an embedder factory, the vector store, and the retrieval modules. Let's open the ones that carry the real work. Chunking is a sliding window. By default, each chunk is 30 seconds with 5 seconds of overlap, so the step between windows is 25 seconds. The overlap means an event straddling a boundary still lands whole inside some chunk. There's a neat detail here. The same span math runs in a second function that predicts chunk identities without touching ffmpeg, which lets indexing resume and skip files it has already processed. Before a chunk is embedded, 2 cheap filters run. One downscales it to 480 pixels tall at 5 frames a second. The other extracts 3 frames as JPEG and compares their file sizes. Similar sizes mean a static scene, so it gets skipped entirely. Embedding is hidden behind a small factory. One function returns whichever backend is active, and every caller talks to the same interface. That's what keeps the rest of the code from caring which model is running. 3 backends sit behind that factory. Google Gemini as the default and highest quality, a local QN3VL model that needs no API key and runs entirely on your machine, and Alibaba-Scope for the cloud QN option. The store wraps Chroma with cosine distance. A query returns the nearest chunks, and each distance is flipped into a similarity score between 0 and 1. Higher means a closer visual match to what you asked for. Crucially, every backend and model gets its own collection, so vectors that aren't comparable can never mix. Chunk identities are a deterministic hash of the file and start time, and writes are upserts, which makes reindexing the same footage idempotent. Search itself is small. Embed the query or a reference image, ask the store for the top hits, then sort them by similarity. Because images embed into the same space, you can search with a screenshot instead of words. The command line layer adds judgment. If the best score clears a confidence threshold, default 0.41, it trims that span from the original file. If nothing's confident, it asks you before saving a clip. One event usually lands in several overlapping chunks, so the top results can be near duplicates. An optional dedupe step sets a similarity ceiling and drops any hit too close to a higher-ranked one, keeping the list varied. What if you don't know what to search for? The Highlights module ranks the most unusual clips. This default scorer measures each chunk's mean distance to its k nearest neighbors. A clip with no near-twin scores high and floats to the top. 3 methods are offered: nearest neighbor distance for general use, plain distance from the index mean as the cheapest option, and local outlier factor when the footage has several normal modes, like day, night, and garage. The local backend stays fast by stacking small wins. Downscaled chunks mean fewer pixels. At most 32 frames are sampled per chunk. Matryoshka truncation keeps only the first 768 dimensions, and quantization plus still skipping cut the rest. On the Gemini backend, the numbers are concrete. Indexing an hour of footage runs about $2.84 since the API tokenizes 1 frame per second. Search queries are just text, so they are essentially free. There's also a Tesla-specific touch. Speed and GPS are embedded inside the dashcam files, and the overlay module reads that telemetry and burns a heads-up display, speed, time, and reverse geocoded location onto the trimmed clip. Finally, the tool plays well with its siblings. Every search writes its result list and saved clip path to JSON, so Sentry Merge can stitch one cross-camera video and Sentry Blur can redact it, search, then hand off with no paths to copy. That's SentrySearch end-to-end. Chunk, embed, store, and search, built from a handful of focused modules around one idea, putting video and text in the same vector space.